Hello, sir. This is Prithvi Kumar, uh, CSCX section. My topic is flow graph construction. What is flow graph? A flow graph is a directed graph representation of a program where nodes represent basic blocks, sequence of straight lines, codes. Edges respect problems execution flow. We can see the 3 points here: basic block, directed edge, and entry exit. First one, basic block. We can see here maximal sequence of constructive three address instructions where single entry and single exit point. No branches in middle. Second one is directed edges. Arrow from block B1, B2, B2 can immediately follow B1 in execution. Conditional or unconditional jump. And final one is entry and exit. Special node marks problem starts entry and exit. All paths originated at entry and terminated exit. Next one is identifying basic blocks. We can see here three steps. In step one, CFG construction, find leaders partition into blocks. First one is first statement. The first instruction of program is always leader. Second one is jump target. Any instruction that is a target of a conditional or unconditional jump in a ladder. And the third one is after jumps. Any instruction immediately follows a jump or branch instruction in a ladder. Next one is CFG construction algorithm. We are having five steps here. Step one, praise and generate three order code. Second one, find leaders. Third one, partition into basic blocks. Fourth one, add address edges. Fifth one, add entry exit. In step one, convert source code into intermediate representation. TAC or IR. In step two, apply the three leader rules of identifying the start instruction of every basic blocks. In step 3, group instruction from each leader or the next leader into a single block. In step 4, for each block B, if last statement is conditional jump to L, edges B block L and B next block. Unconditional jumps and only B block. Step 5, add entry and exit nodes. Insert a virtual entry node connected to find blocks and exit node connected from blocks and terminate execution. We can see the code snippet here. Dominators and loop detections. Dominators. Dominator node n is every path from entry or n must pass through D. As natural loop, a back edge th exists when dominate T in the CFG indicates a loop. D is the intermediate dominator of N. T is a closest dominator of N other than N itself. Natural loop is equal to union of all nodes that can reach it without going through H. Dominator tree edges from IDOM N for all N from a tree rooted entry. Loop header. Single entry pointer of the loop preheader is um, inserted of optimization, critical for detecting natural loops and motion SSA construction and registration allocation. Natural loops, application loops, uh, codes motion, induction, variable elimination, loop unrolling, and vectorization. Here we can see the applications in a control following analysis. There are six different types: dead code elimination, data flow analysis, loop optimization, register allocation, SSA from construction, software testing, and security. At first, dead code elimination. Node unreachable from entry in a CFG representation dead code. Removing them, reducing binary size, and improve cache efficiency. While coming to the data flow analysis, reaching definitions, live variables, and available expressions, all programmed along CFG edges. We can also see the loop optimization using back edges and dominator tree identify loops. Enable CILM loop um, invariant code motion, loop unrolling strength reduction. While coming to the register allocation, we can see the liveness analysis over CFG determinations where variables live at each program point. We can see SSA from construction, static single assignment uses dominator formats to place functions at match points for optional optimization. While coming to the software testing and security, path coverage, branch coverage testing CFG, used in symbolic execution, fuzzing, trait analysis, and manipulated detection. Summary: these are the key takeaways. We can see flow graph models, program execution. Basic blocks are building units and dominator reveal program structures and CFG driven all major optimizations. Beyond beyond compilers testing and security. Thank you.